Welcome to Patterns for Scalable Security Detections on AWS. I'm Andrew Krug. I'm a security geek at Datadog, specializing in the cloud, especially identity and access management, in addition to cloud security. And I'll let Justin introduce himself.
My name is Justin Massey. I'm a product manager at Datadog, and I work on all things threat detection.
Today, we're going to talk to you a lot about logs. Of course, we're a logging product, so it seems like a natural fit. You're going to understand structured logs versus unstructured logs. We're going to identify some inconsistency and misinformation in a variety of log sources. And we're going to visualize and investigate security issues across a bunch of log sources related to this topic that's really near and dear to me, authentication. But you're going to hear more about that in just a bit. Our thesis statement here and kind of the purpose for this talk, which is that your business is drowning in log data. You probably have both structured and unstructured log sources filling up your data lakes without any real consistency or sanity in the way that they surface common portions of log taxonomy, specifically around authentication. And if you just apply a tiny bit of thought, purpose, and measurement, you can use those logs for some really meaningful detection and alerts. So let's just jump right in here and take a tour of those potential log structures. So in AWS, you may be a customer of one or more of these products. You might have something like Amazon Detective for doing investigation, but you also might have logs that you get from things like DNS, VPC flow logs, AWS CloudTrail, EventBridge, Config. If you're using security products, things like GuardDuty, Access Analyzer, you might be aggregating things from other tools like Datadog, or you might be using tools like the AWS Audit Manager or the compliance reporting that exists in Datadog. And then there's application logs. You have your own custom tools that you're developing, likely internally, and those output logs in a variety of formats depending on how much logs are part of your software development lifecycle. On screen here, you can see an example of an application log in Datadog, but you can also see that the message that we're looking at in this example is not necessarily extra useful. So the age-old supposition that if you have some logs from the cloud provider and some application logs, and you're taking the effort to store them, results in security detections. But this in itself is not actually true. So just the act of storing logs, like going and getting the logs into one place, isn't really enough. What we've tried to do as a security culture in the past is this thing called normalization, right? It's a tried and true tactic for finding logs at the source and putting them into a single format, or maybe you have some kind of log pipeline that puts them into a normal format, but it tends to be a one size fits all structure. Either logs fit in the format or they don't. And this method hasn't historically handled the absence of fields particularly well.
So today we're going to talk a lot about the different kind of log types, and we want to talk about the users who are interacting with those. And we're going to talk about how the users are interacting with the services, such as different AWS services, and the applications that sit on top of these. And a good taxonomy is going to lead us to being able to pivot around these things very well. And we're going to talk a little bit about why. So first off, basic alerts only go so far. If you just receive an alert for, say, something for an authentication attempt saying that a user failed to log in, or you may have a GuardDuty alert that says your EC2 instance is mining crypto, currency. This is not enough information. You need additional contextual information, such as being able to pivot to metrics from that EC2 instance. So if that GuardDuty finding said that you are mining crypto and you look at your CPU and you're spiking, that may be more contextual information. So when you're investigating that incident, that additional information is key. So we want you to have access to your user data, the application data, the underlying application that's running on the systems, and the control plane data, what is happening, inside of AWS. If you have those three pieces of information, you're going to be a lot more successful. Now, we want to make sure that the application logs, you can interact with the logs in the same way you access your control plane logs. So I'm going to show an example here. And this example is this widget, this dashboard showing you things like the username. Jonathan Johnson is logging in from this IP address. And the source of data here is CloudTrail. So this is Jonathan Johnson logging in into AWS, and it's from CloudTrail. Now you'll also see that you have Ruby logs, which is your custom, maybe a custom application, as well as Okta and Auth0, some identity providers, all showing up in the same page. And if we were to see, the same users failing to log in across sources, this may be indicative of some sort of attack. And we want to be able to visualize these, in different sort of widgets so that we can, not look at data, as just logs themselves, but visually as graphs.
And I just want to point out here, in case you think we're getting a little bit ahead of ourselves, that this is actually a dashboard from Datadog. So all these concepts that we're talking about, you could apply to any tool that you have to bring these disparate bits of information together. But really, it takes this thought, purpose, measurement, massaging of the log data to get to this end goal state. And next, we're really going to talk about how we get to that end goal.
So in this log right here, we see John Doe logged in. This is for a custom application. We're going to assume that things like AWS and their CloudTrail logs are logging all the information you need. But for your custom applications, and I've seen this in many applications, they don't include all the information you need. So here, we ask a couple questions: the who, what, where, and when. We can answer who from here, logged in, John Doe. We don't necessarily have the answer, the full answer of what. So we know that they logged in, but you may want to know, like, what they logged in with, whether it was a password or OAuth or SAML. And you sure don't know where. You don't have an IP address, and an IP address could give you a country maybe. And you do have the answer when, which is the timestamp at the beginning. So let's take a look at what a better example looks like on the next slide. This now has the what and where answered.
But all we really did is add some additional context, right? This still isn't the best format that it could be in, right? We want to take it one more step.
Right, and so we have this additional information now, but we need to be able to parse this in our log product in a very easy way. But we also want it to be, and you may say, well, why don't we just put it in JSON format? But if you've ever read JSON like on a log file without it being parsed, if you like log into the system or the container and tail a log file, it's very difficult to read JSON. So I'm recommending a hybrid. Use key value pairs that are readable. So if you see user.id equals John Doe, that is, the user ID namespace, or the key value or the key, and then the value is John Doe. And you'll see here that we've put John Doe in quotes so that the machine, that's interpreting this knows that John Doe is an entire string. So these are, this is just an example of how you can visualize this as a human and as a, able to interpret it as a computer. Now, you'll see that AWS CloudTrail authentication has very similar information. They're in different locations. We still have the IP, which is in the source IP address field. And you have the user, which is in user identity.username, and so on. But the thing is that if you want to look at these across CloudTrail and your custom authentication logs, you need to do, these need to be in the same attribute. So for here, source IP address in CloudTrail should probably map to the same IP address attribute in your custom authentication logs, which in Datadog, our standard attribute for IP address is network.client.ip. And we have recommended standard attributes for all of, for a variety of different attributes.
Yeah, so what we're really doing is we're instead of doing that normalization act that we talked about before, which is trying to go to every single system in our fleet of potential systems and make the logs put them in the right format before we ingest them, we're actually using the event aggregator itself. In this case, Datadog has this great log pipeline feature, which is called the remapper, that allows us to do this kind of really, really super easily. But you can do this, apply the same tactic to a variety of tools. So let's talk about enrichments, which is kind of the next level of adding additional context to events, besides just kind of getting logs in that standard format. When I think of enrichment, the act of adding some more information to a log that gives us more context, the most classic example I can think of is GeoIP information. So is this coming from France or Russia? And depending on where you spend most of your time, it might be normal for you to come from France, or it might be normal for you to come from Russia. In terms of your ISP, is it coming from the same ISP that you usually use? And then I know you have some thoughts here, Justin, on some potential detections.
Yeah, so for this example, if this is a user logging in from this IP address, you said does this user always log in from France? We can use a detection method in Datadog called new term, and we can say, let me know when a new term is detected from a log for a user. So this could say, let me know when a new country is seen for a user. So France may be seen all the time, but then when they log in from the US or Russia, you would detect that. You can also use impossible travel to detect when a user logs in from different locations that it would be impossible to get on a plane or a train and get access to. So that's another detection method you can use with GeoIP. The next piece of enrichment that is nice to have is threat intelligence. From an IP address, you can know whether this is a known threat actor. This is possible by companies such as Gray Noise. Gray Noise has listens from many different servers across the internet, and they can see whether a known threat actor is, whether an IP address is scanning the internet. Maybe it's just something like a Google bot scanning, and it's harmless. Or maybe it's a nation state, or maybe it's just a script kiddie that's scanning the entire internet and then trying to do malicious things like trying to exploit a vulnerability. With this additional information, it is really helpful when you are investigating. I wouldn't recommend, though, that you just generate an alert every single time you have a match on a threat intelligence list, because you're going to get inundated if your application is big. So please use this, for enrichment and investigations, not solely for detections.
So what about this, like this concept of cloud provider IP ranges that many of the popular cloud providers now publish? How could we use that for some meaningful detection?
Yeah, so Amazon publishes this information and will include different things like the AWS service or what region it was. So if you fetch a credential via STS and you use that credential, if it's not necessarily coming, so maybe you fetched it for an EC2 instance, and if it's not used on EC2 instance, it's used from somewhere that's not even associated with AWS, this may be a concern that your server has been compromised, or maybe you have like an SSRF vulnerability that's you can detect because this credential is not used from the location you expect. So this is a great use of additional enrichment such as the AWS IP addresses.
So let's talk about detections, where kind of the boots meet the ground here. What could we actually do now, like applying some of these tried and true tactics and the standardization to detect things in your account? The first one I can think of is users logging in without MFA, right? We know it's good to use second factor authentication. CloudTrail gives us all of that data and surfaces it in a single key that we can then match on and we can use to do a detection. That one's the simplest.
To go a little bit more complex, we can detect that a security group is open to the world. So we look for any time that you have an event name such as authorizing a security group for ingress, and we look deep into the log for the IP addresses that are allowed, and that's contained within an array. So you have to go access items within the array, and you can look for things like 0.0.0/0, which if you're familiar with networking, you would know that that means all IP addresses. So any IP address can access this. So this is something that you would want to alert on and just, talk to the developer who created this and say, is this needed, or can we type more? Can we, scope this down to be your IP address or maybe the office IP address? So this is definitely something that you should, keep an eye on. Now, a little bit more complicated is things like credential stuffing. This is not matching a single log, but it's matching many of logs. So you can detect, and you can use Datadog for this, you can look for, say, when a single IP address fails to log in from over 100 unique users and it matches a given filter, then, let me know. And you can go one step further by saying, if you had 100 failed logins and then a successful login from that same IP address with different usernames, this is something that is a really good detection strategy. Credential stuffing attacks are becoming more and more broadly used, unfortunately due to credential reuse.
Yeah, and this is a great example of how powerful a good tool is, right? Because these two events all by themselves, a single actor logging in successfully is not really something to write home about. But if we see 100 failures followed by a success from the same client IP, that's something that we know with a high level of certainty that the security team needs to take action on. So this is really kind of my personal easy example of an actionable alert.
So just to recap what we've talked about here, we have 3 different security findings. We have a user logged in without multi-factor authentication, a security group that's open to the world, and a credential stuffing attack. What you may not have realized in those 3 previous findings that we showed on the screen is that they all had the same username associated with them, which is John Doe. They all had the same IP address. However, they didn't all have the same source. So you can use a product after you've normalized all of your logs into the standard attributes. You can quickly see that there is a common theme here from this user and this IP address, and this is something that you want to take a look into. Now, I want to talk a little bit about identifying changes and missing logs, because I see this happen in many different orgs. Many different customer environments when I talk to customers. And we'll first talk about what it means to have like a change to a log. Developers may change their logging structure for one reason or another. And on day 1 or day 0 in this example, you can see that there is a attribute called network.client.ip. But what happens when a developer makes a pull request and changes that IP address, or something happens to your processing pipeline and it changes to client_IP? Well, you should be able to detect this and make sure that this change is detected. And the next step is, what happens when this log or this attribute just disappears? You need this information, for auditing purposes and alerting purposes. So you want to make sure that your log hygiene is healthy.
Yeah, we can actually use alerts to detect the absence of that field suddenly, because what we don't want is to have false negatives. We don't want our alerts just not to work silently because all of a sudden now we're missing a field, right?
Yeah, that's exactly right. So we're going to talk a little bit about missing logs here. And missing logs is when a log just disappears. Maybe a log source just disappears. So I'm going to hand this over to Andrew for this one.
Yeah, so this is classically talked about as a dead man alert, which is kind of an old term, but what it means is that you might be in a multi-org reality. In this example here, we have lots of different account IDs sending you CloudTrail logs, and then all of a sudden, just one kind of stops sending logs for no reason. So if we just have an alert that says, "Tell me if I'm getting CloudTrail logs," it's not going to detect this single example. But with this no log concept that we kind of talked about, we can actually look for the absence of a specific recipient account ID. So it's a no hit count over a time window on not seeing a specific account ID. And that's really, really powerful because it kind of takes dead man alerts to the next level, not just, hey, we're not receiving any logs in the last 15 minutes at all. It's the next evolution of that kind of detection. And now I'm going to hand it back to Justin to do a quick demo in the Datadog platform to recap just how we put all those logs together to generate a series of meaningful alerts using authentication data.
In Datadog, you can start your investigations by using out-of-the-box investigation dashboards, or you can create your own investigation dashboards like I have done for this presentation. In the top of this dashboard, I have defined security signals, which show the different rules which have detected security signals, as well as the users who are associated with them. And in the left-hand column, you can see the source of these. So for this, our custom application is written in Ruby. You can also see that we have CloudTrail signals, which are coming in from CloudTrail logs. Now in these investigation dashboards, you may want to ask very pointed questions about different sources. For example, in AWS, you may want to see the top users who are acting in your AWS account. You may want to see the AWS accounts or the regions you're active in. For your custom applications, you may be concerned about the authentication events. Here you can see that the admin user is failing to log in 955 times. You can also see that the user authentication logs here, which would pivot you into the log management product and allow you to explore further. But first, let's take a look at something we talked about earlier, which is standardization of attributes. So for this one, you can see that the username column has the username admin, Zachary Wilson and Stephen Davis. However, these are over different sources. So we have standardized these on a username attribute. Now this is really nice because if I want to see if I want to filter this entire dashboard for information on Stephen Davis, because right now I only see that they're active in CloudTrail or active in AWS. You can click on Stephen Davis's name and say set username to Stephen Davis. Now it's going to filter the entire dashboard down to that. So now we can see that we have two different security signals for CloudTrail, but we can also see not only that, but that Ruby has detected that this user has failed to log in 59 times. We can also see he's active in this AWS account and this region. But let's dive into these custom application logs. We can click on this log here, and it's going to open up the log management product to this specific authentication event. You can see that it occurred on this EC2 instance, and if you wanted to see what was going on this EC2 instance, you could click on this and view in the host dashboard. You could see what's going on with the network. You can also see any of the metrics associated with it, so you can see that the CPU started to spike at this point in time. Or you could see all the related processes, which this is interesting because there appears to be a crypto miner process. So you may want to start an investigation from there. But let's continue down this specific log. We can see that the continent it occurred from was Asia and the country was Japan. So if this user typically logs in from the US, that may give you information that this user is under attack. Also, you can see that this username is also enriched with a team, such as engineering. This is additional enrichment that may help you, identify sorts of attacks. If Stephen Davis were performing activity inside of AWS, but he wasn't on the engineering team, this may be a concern to you. This is a way to quickly, begin drilling down into the details of these logs. Now, let's go back to that investigation dashboard. Let's now take a look into some of the security signals that were created for this user. So we're going to see what security signals were related to Stephen's username. And we're actually going to look at all of the VPC created or modified for Stephen Davis. Now we're looking at the security event that says that Stephen Davis created or modified a VPC. Now we can see exactly what he did was he deleted a VPC. This was the event name from the AWS CloudTrail log. All of those events are, have event attributes associated with them. So we can see that he created this. He was using the AWS SDK, and we can also see the IP address associated with them, and that it was an IAM user and not a assume role call. Now, if this is indicative of an attack, you could quickly share this to your team on Slack, or open up a security incident from here. Now, to bring this full circle, let's take a look at what this would look like in the Log Explorer when you pivot to that pivot there. So this is going to filter down all of the logs, from CloudTrail, from all of those VPC change events to Stephen Davis. But if you're interested in things that Stephen Davis is doing that aren't associated with VPC, we could remove this event name from the query. And we can also see that he's also deleting trails and disabling rules. This looks like a user that may be, performing, some deletion or destruction on your AWS environment, and you want to begin a security investigation from there. Now, with that, that is the end of the demo, and back to you, Andrew.
Thanks so much for attending our talk. Once again, I'm Andrew Krug, Technical Evangelist at Datadog.
And I'm Justin Massey, Product Manager at Datadog.
Please don't forget to complete your session surveys. If you like the talk, do a session survey. If you didn't like the talk, do a session survey. We love to see your feedback, and feel free to reach out or engage with us on basically any platform you can find the two of us on. Thanks.
Thanks, everyone.